My name is Lukas Krattiger. I'm a principal engineer working out of the Cisco Data Center Network Business Unit. So as Jerry already said, we're owning pretty much everything which is labeled with a Nexus or with an ACI or with a DCNM or everything around that area. The story is simply around Data Center Network Manager. We went through numerous iterations of Data Center Network Manager. Any one of you guys saw it in the past? It was called SAN Fabric Manager or something like that. That was Grandma's one, so we're now at version 11. 11 is approximately 18 months old, so it's not brand new, it's exciting new. It's actually nicely matured over time, and we want to tell you a little bit about it. And we want to tell you what we actually put into this new thing in DCNM 11. And as you can see here, it's not anymore just one DCNM. It sounds strange. No, we didn't create a multiple product. It's one single product, but it has different modes you can use. So we have different install modes, which you can select actually the same software type in their respective operational mode you want to see. Now, classic LAN is what we called DCNM LAN in the past. It's basically you click something and it executes something on the switch. So very boring, so it's a CLI abstraction if you want so. We have SAN, that's where the original part comes from. And then what we did very recently is what we call LAN Fabric. And that's what we're going to talk about more extensively in the next couple of minutes or so. And I hope my demo works. Demo gods are good with me. Now, paired with the LAN Fabric, we also came up with what we call a compute node. You can guess that today you have multiple applications running in your data center network manager, so on the management operations side, and somewhere you want to host them. I can tell you, you go and install hundreds of servers and do your open source deployment and so on and so forth, or I can give you kind of a turnkey solution from an infrastructure perspective, from an appliance perspective, and run that stuff on top of that. So DCNM extends naturally into compute nodes, and you install it as it would be a DCNM, just in a different mode. Last but not least, on the bottom, media controller. We're very extensively working with the production networks, multicast networks specifically, professional media, and that's where the media controller comes in. It's basically a smart multicast controller, which understands how much bandwidth is available in your network, where you want to have your streams actually set up, and make sure that there are no oversubscription and specifically no drops in that multicast network. So that's the media controller. But all of this is DCNM. So it's the same bit, it's the same install. You just select what you actually want to do with it, and then you go forward and run your network managed out of that tool.
So question for you on that, because I actually work a lot in the multicast space and the IPTV space. And is this only like for streaming media and multicast applications with like over the top inside the data center, or are you also seeing this for like head ends, broadcast, video type head end work? Yeah,
so it's for production networks. So we actually run a couple of very famous TV studios on top of that.
Okay.
So it's the production work stream, which are transforming from the classic PDM or ICN kind of approach into an IP multicast approach.
Okay.
And that's the controller side on this.
Gotcha.
Yeah. Yeah, it's just a little bit there, but sorry that I don't talk more about that today.
No, that's okay.
We could actually, but I'm driving into the LAN Fabric now.
Just curious.
Of course, please speak. As said, LAN Fabric is where we want to focus on, and when we look at DCNM, it's a classic inventory provisioning and resource visualization which we have up there. And then with the LAN Fabric mode, we actually went into the full life cycle, the full network deployment life cycle or management life cycle, and that's where we start with day 0, day 1, day 2. You guys are aware of these terminologies, right? Day 0, I want to build my network. Day 1, I want to continue, expand, and then day 2, I want to do the operational part, day 2 ops part, which then Tim will extensively talk about that. So this is all this same DCNM, and you see here actually the compute nodes coming out, sliding out, and the application framework over the top, which is providing us the ability to run on that single operational infrastructure tooling different functions and different tools which are required to basically complete that life cycle in there. So you will see a lot of this not, because it will be under the hood, but this is actually how it looks like. DCNM, the compute cluster. You will probably hear me talking about the application framework, which is one of our microservices infrastructure we built, and you can actually run it on top of an appliance, which we are going to provide.
What's the difference between ACI and the DCNM? I know, ACI, at least from what I can see so far, has a bit more capabilities, but why create two different products?
Oh, that's a fantastic question. So when we look at ACI, ACI is changing the network consumption model. So it's that whole good intent-based networking approach, so you don't really care what's running underneath. Now, there's still customers which are very in the native or in the legacy kind of operational mode, or didn't want to make that jump over to SDN solution as a whole, and that's where DCNM comes into the picture. So DCNM runs NX-OS switches. So you're still your individual switch. It's your DCNM over the top, which takes care of the configuration and the management of your network. You still have access to the CLI if you want to. It's still individual nodes, and it's still the classic feature set which runs on the switches down there.
So is DCNM actually doing overlay as well, or is it just fabric underlay sort of management?
That's a fantastic question as well. So DCNM does overlays. Okay. DCNM introduces overlays, not on the server side, but on the network side. So we're sticking to our switch capabilities,
so like
our Nexus switches. Absolutely, we run VTAPs, and let me see if the next slide makes actually sense, because that's where we are here at that third point. So we're building networks in DCNM. And we're trying to abstract these networks to a certain extent. So this new install mode, specifically the LAN fabric mode, helps me to have workflow-driven network creation. I don't want to say intent, otherwise I need to take two shots, but it's you basically saying what you want to have instead of configuring the OSPF process. When we go back to things like LAN Classic, which I mentioned before, you would say, I want OSPF process 200 on this interface. Very low level of intent. When we're going here, we're a little bit higher level. We say, I want to run a fabric, and that fabric should run an overlay, or that fabric should run a complete routed approach, like the eBGP RFC 7490, the BGP eBGP routing MSDZ fabrics, however you want to call them, right? Or you can even go there and use it same as LAN Classic, but in a closed loop automation, meaning what you send is enforced, and if somebody goes into the switch and changes, the configuration compliance comes back and tells me about that. So it's a kind of a half intent, if you want to call it, from that full life cycle there. But that's exactly what we're doing. We are modeling configurations, we are deploying these configurations, and we are ensuring that these configurations are really there in place. So you can go destructive, absolutely, but we will tell you about that, and we were able to give you a reconcile. Cool. Going forward, and I said probably everything about this here already on the slide, so we go a little bit forward, one step forward. In LAN Fabric mode, or in the LAN Fabric install mode, there is a quick set of tools which we are providing, and we're putting that umbrella under the name of Easy Fabric. Now you guys know what I meant with how many times I'm going to say fabric, right? It's the LAN Fabric, the Easy Fabric, and yeah, however. Now this whole Easy Fabric construct should help you to do the plumbing at first. I mean, you have to go and plug it in, right? The switch needs power. Needs somehow a connectivity, preferably out of band, but in band works equally. And then we basically can bring up the network by bootstrapping it based on a complete empty switch. And the beautiful thing here is I don't need to know a serial number. I don't need to know an IP address. If the switch is in that power and auto provisioning mode, he will recognize that there is a DCNM in the network, and he will register against DCNM, and you will see the list of switches available. From there, you can select and go on at that point. This is not the only install mode. And I think, as you see here, there is something we call greenfield discovered. So if you don't like to have a DHCP server in your out-of-band network or you're in your in-band network, and you decide to put the IP address first on the switch, and then you want to discover it. So we can do a full greenfield discovery of these switches, and that's what I'm going to try to show you guys later in the demo. Last but not least, which is, I think it's the most complicated thing to do these days, is brownfield. So having an existing network and trying to assimilate all of that configuration into DCNM, right? So let's take, for example, we did this with VXLAN EVPN. You configure it by hand. You guys know how many lines of CLI you probably could have. And we're going to, trying to understand this. We're taking IP addresses for point-to-point routing and populate it into the resource management we have in DCNM. We're going to take your OSPF, your ISI's configuration. We're going to look at your EVPN configuration you have in there, your VNIs, right? The networks and VRFs you deployed, and we show you that subsequent in DCNM once we imported that. And that was one of the first iteration we did with DCNM 11. That was actually when we took the Nexus Fabric Manager functions and migrated them into DCNM 11 and allowed the migration to be completely zero touch by not taking one tool database into another tool database and try to model stuff around. It's by pattern recognition and by template. And the DCNM configuration function is all based on a policy construct. It's we call them micro policies, so it's some little snippets if you want to, little config-led snippets. We ship them with the product, so you don't have to create them, or you can create them on your own if you think some of these configurations don't make sense to you, you want to have it differently. But overall, we build a whole list of these templates together, concatenate them, take the resource management in, and create a configuration at the end, which will be deployed on the switch. And now when we go back to the configuration compliance, we're not matching one config file against a full other config file. It's a subset, an intent template, a policy template if you want, so against what is actually in there. So we understand what an interface means. We understand what a routing protocol means. We understand what VLANs mean and try to not only abstract them, but also move them into DCNM and make them available for you. Make sense? Cool? Boring? You guys want to see it, right? You guys don't believe it. I'm sure that you don't believe it. So I don't believe it. I didn't believe it when I saw it first, but it actually works. Still, data centers might have multiple tools in there. And when I want to integrate a domain controller, let's call DCNM a domain controller for a set of infrastructure in my data center, maybe I want to hang that into another domain controller. Maybe I have ACI there, maybe. But I'll try to normalize my deployments in a way I want to have the same IP subnet or network or whatever communicating together in a certain way. And that's where the northbound API comes into the discussion. So DCNM is actually all what you will see is running on top of the REST APIs. So even the UI of DCNM itself is running against the REST APIs. So everything what I click, you can actually do. On top of that, you can build your own workflows and run them against the APIs. And you're pretty much happy then on what the outcome is because it's an abstraction of what this networking fabric or the switching fabric does against what you want to do or want to build in your logic.
So I've got a question for you. I'm just curious. Cisco's had a few different products over the years that have dealt with data center automation, orchestration, and some of these things. What differentiates DNCM from things that you've done in the past?
I don't think it differentiates it from the past. It's actually a thing from the past which got just modern over time.
Okay.
So as DCNM, I think I started working on DCNM 7. That was probably 8 years ago.
Okay, so it's been around a while.
Yeah, it's well, DCNM 6 is even older, and before it was SAN Fabric Manager, which was the core of it, and then we merged it into Data Center Network Manager. Okay. So it's actually around for quite a long time, and the tool set which is in there in the core of the platform has been revamped over the time, so modernized. Microservices as one example, which we did in the very latest version. But we kept all of this knowledge of how to interact with certain systems from an MDS fiber channel switch all the way to the most modern Nexus switch we have in our portfolio.
Okay. So is this something that would be considered complementary to like ACI?
Absolutely, yes. So as said, we have a lot of customers still running NXOS running a 5K or a 7K or even a 9K in NXOS mode. This is absolutely complementary to this. When you think of data center cores, even in ACI, you might have a couple of boxes which are running NXOS. Complementary to it, right? You can manage your network there, or you can just run in a complete standalone fabric mode or NXOS fabric mode, VXLAN, AVPN, BGP, whatever you want to. Not everyone is there and wants an ACI turnkey solution, so there is actually a turnkey solution for NXOS on top of it.
Okay.
I feel like their capabilities are really similar. What would be a good use case for why you would implement both?
I don't want to look at them as competing in a way on one versus the other. It's really what is your operational model on that side. What way you want to go as a customer and look at it. And there are a lot of vendors out there in the market saying, hey, that's my way or highway. And we have a certain set of customers which are with us for a very long time. We want to make sure that these customers are happy. We want to make sure that other customers which have another view of building networks like the massive scalable data center customers, that they have also an operational model they like. For that, we have other modes on our switching system. But it is really what you like and how you like to operate your network.
Earlier on in one of the slides, you talked about how this product is supporting a hybrid and multi-cloud.
Yes.
Is that something your guys are building, like the overlay into various cloud providers or something? And if that's the case, then how's that done? Are you guys doing like virtual router type function that you deploy inside a public cloud? Yeah.
Yes. So Jared was talking about that. Yes. So we have a hybrid cloud integration. So we have a set point in the clouds. We have Google, Azure, as well as AWS. The Cloud Service Router 1000V is pretty well known. And DCNM actually manages that entity out there and allows you to extend the VRFs you want to have up there, ensures the security, the IPsec part there, and make sure that it comes actually directly from your data center on-prem fabric all the way into the cloud. And this also, maybe to complement what you said before, happens on the ACI side as well as on the standalone NXOS side. So we're trying to make automation pervasive, that there is no gap between one or the other. So the operational model you want to run your network with decides what you go versus capabilities, and trying to do the matrix and say, okay, I get knob there is on the left and that knob there is on the right. I like it on the right, so I'll go to this model over there. We want to make the functionality more pervasive there.
Where's this headed with DNA Center and feeding into that? Sure. Is it?
No, it is. It is. So Cisco has a very strong view on multi-domain. Multi-domain is campus, data center, service provider, as such. And the domain controllers, that's what we call them, domains, are there with very specialized know-how. And we want to keep them there with very specialized know-how, but there's interaction in between them, and that's where the APIs come in. And that interaction on the top with DNA Center, for example, there's pairwise integration, which is DNA Center to other domain controller, or then is a more abstracted model where you have a single pane, of glass, which you can go through and operate that. We do that actually for quite some time with NSO, Network Service Orchestration, which was an acquisition we did with Tailef some time ago. So there's a lot of that stuff going on. Okay. All right. You guys want to see how it works? Let's see if that goes. So I'll have to split the demo in two parts. And the reason is very simple. I don't want to let you guys wait too long. So for the first part, I'm going to discover a little kind of network here. It doesn't look very fancy. Couple of switches. I will create a fabric. I will show you what fabric options I have. I will go and import these switches. I will discover them. You remember I mentioned that discover greenfield, so the switches are empty. They just have an IP address set. After discovery, I will set some roles, and then I will make sure that the configuration respectively is prepared, staged, and then pushed, and that will take a couple of minutes. So I will switch over while this is going on and show you what we do with an existing fabric. So this fabric is built, looks pretty much the same as the one before. It actually has one switch more here, which you will see then. It's a slightly different type of switch, but it's the same OS running on top. It's a couple of Nexus switches, one of our cloud scale portfolio here. And what I will do on top of the existing created fabric, I will create VPC. So you guys remember VPC, virtual port channel multi-homing or something like that? How many lines of configuration you guys did in order to do that?
A couple.
And how many times you missed all the best practices?
Yeah, more than a couple.
Happened. Okay, so we have a precedence here.
What, there are best practices?
Here we go. I will run a VXLAN on top of it. So I'll create a VRF and I will create a network. Network is for us a layer 2 VNI or layer 2 segment with a first hop gateway. So we use that distributed gateway and such. And then I will attach, actually the VMs are already there. I will just create a port channel here, a VPC, make sure that the connectivity happens there and that these two VMs can ping to each other. You guys probably need some stronger glasses because my screens are very small for the pingers. Just go then, and that's basically then the end for the demo, and we can do more question and answer. I'll try to show you a little bit of how the policies looks like, where you see the policies, those options you have. In fact, you can build this in probably less than 30 minutes without a single change. Or you can go crazy and change every single knob which is available on the CLI. Everyone good? Yes? All right, let's see if that goes. Let me switch over to Data Center Network Manager 11.2. Doesn't switch. Okay, let me see. All right, so we like our bridges around here. Let me see if maybe I just sit down. That probably gives us a little bit more real estate. You guys can see, right? It's big enough. Okay. So
Data center what?
Data Center Network Manager. Splash screen, I increased a little bit the size, so that's bigger than what it normally is, but it should work well. I'll have a fabric already configured there. As you mentioned, I said I have a demo fabric being built. I leave them just on the side, so ignore it, that it even exists, and I'm going to create a complete new fabric together with you guys. Fabric Builder is our tool. We have our menus slightly structured between control, monitor, and administration. Topology, we'll show you afterwards the topology then. But the Fabric Builder is where I start controlling my entities and where I try to build my new fabric, and that's what I'm trying to do here. I need to give a fabric name. Not very magic. I guess everyone likes a name to or name something. And here you see for the first time different fabric templates. So this is actually the magic behind Easy Fabric, which creates all this modeling of configuration, put the policies together, and make the switches at the end working as they should. It is a template you can edit. There's a full template library, and you get access to that template library whenever you install DCNM. It's under control template library. You'll find it. In this specific case, I'm going to create this Easy Fabric here, and it asks me to enter a couple of attributes. We're following the mantra of the minimal amount of input to get the maximum amount of output. It's great for customers who just want to try something very fast. So I want to hear an AS, and we'll try to do a private AS. I want to use point-to-point, so I will allocate out of an IP subnet, out of a scope, point-to-point. Here's a /30. I could change that to a /31. I could do OSPF. I could do ISIS. I could do 2 route reflectors. I can do 4 route reflectors. So this is already in mind with a VXLAN EVPN fabric when we see this here. I can go on with more modes. I can say I want multicast replication. I want ingress replication here. So all of this multicast complexity goes away from me. I don't care on it. And you see here, I literally have pretty much every knob you could think of, how you like it to turn, but I don't have to, right? You saw me, I entered an AS number, but the very first one, I changed to ingress replication just because I don't want to enter a lot of other things or think about multicast, and I can say save and add switches and I'm done. Okay, I'll do one slight change simply to speed up things, and we have here a way to not write erase the switches. They're already empty, but I'll go and import them as they stand. But this is my empty fabric container I created. So let me go just very shortly back. You saw before we had demo 11 only. That was my build fabric. Now I have NFD, which is a completely new build fabric. If I don't like any of the settings I did, I can go and change them here.
That kind of brings something to bear.
So it looks like you're using it to create like a green field fabric,
Yes.
right? Can you use this to import a brown field that's already established?
Absolutely.
Okay.
Absolutely. So let me actually go exactly to that point. Once we created the construct of what we call a fabric or container, whatever you want to call it, it's an empty bubble, right? It's something where I store something in it. From there on, I can add switches, and I can add switches in multiple ways. I can just go into power and auto provisioning and look what switches were discovered. So who talked to DCNM and registered against DCNM. So I get the whole list of them. There's none of them there. I can actually create an empty switch, just a placeholder with a serial number, and whenever that switch comes online over power and auto provisioning, I will take it into the fabric and I will deploy it with the respective personality configuration. I also have the possibility to discover existing switches, either by seed IP or by list, and I'm going to enter here a seed IP and a username and a password. I'll stick to 2 hops. I will not preserve the configuration, which brings it back to the question from you. I can actually preserve the configuration. That means that I will import everything which is on the switch, compare what I import against what the fabric actually is supposed to be, and I tell you what matches and what doesn't match, and you can reconcile. When I reconcile, it can be disruptive. That depends on what your diff is. For example, I have IP1 and IP2 on that link, but I want 4 and 5. You have to change IPs, that's a disruption, so that's not really the tool, but the tool would recognize these things. So let me go and discover some switches here. I will not preserve the configuration. Yeah, there's a little red thing which tells me go and search for, and you see here it discovered all of these different switches. I have 2 border leaves, I have 2 spines here, and I have 3 leaves, and I import that. Yes, I want to erase my configuration. I say I don't want to preserve my configuration in that case. And now we're going through the discovery process. So this is not magic yet, right? It's a little bit of login with SSH, a little bit of logging against NX API, a little bit of SNMP, just to get these objects and to understand what these switches are, what capabilities they have. I, on purpose, have here a different switch in there. When we would go a little bit further in this whole configuration of fabric, you would actually see that that switch has a certain function missing in hardware. So you would not be able to enable that function
Is that
in your
different Broadcom chip? Is that what it is?
This is one of our first generation Nexus 9000s, which is
Right.
with the tandem chips, the Cisco and the Broadcom chip. And
Okay.
yes, exactly.
So maybe you can do the layer 3 VTEP on the...
We actually can do the layer 3 VTEP there, but there's some multicast restrictions there. We have a mode or an overlay multicast, which is called tenant router multicast, which is like MVPN. These switches don't have the ability, given the tandem approach, which is there. Okay, so you see here the switches are slowly being discovered, and you see very, very slowly here there is a little red tab which actually is migration mode. If we would preserve the configuration, that migration mode is actually an indicator that I'm going to parse all of these configs and import them into my DCNM. As we go here, and I promised you to show a little bit more of building this fabric, I have here a switch, and this is a simple top-of-rack, single rack unit switch, which I normally would use as a leaf or as an access, and I want to actually give him a different role. I want to use him as a spine, and by selecting the role, he will subsequently get a complete different configuration than a leaf or a border node in that case. So this tagging of these switches, these capabilities, they have, and with that additional notion of where it belongs in the fabric topology, will be used to generate the configs.
So I guess there's an assumption here, if you're going to take a switch and put it into a completely different role, that you have to have an out-of-band management network set up that this is interacting with, so that you can interact with the control plane without, Without losing access to the switch.
Yes, so I'm using an out-of-band management here. So I'm using management 0 and a completely separate out-of-band management network. I don't have to. When we do in-band bootstrapping, we are connected at least to one switch and then go in-band with respective DHCP relays and relaying of the POP information we require through. So we can actually do in-band as well. And so you would not lose that. This is specifically interesting when you go in an overlay-underlay network, VXLAN network, for example. You use your underlay as an in-band network for that and go there. Here, I'll give them here a border role. You see I have various different roles, various different functions. DCNM maps pretty much all the functions we have in NXOS to build such fabric constructs. We bring into DCNM and it comes piece by piece. Whenever you upgrade the software on the switch, the software on DCNM will recognize some of these pieces and then enable them whenever necessary. So you see me here, I have a hierarchical network here, a leaf, spine, and a border. I have neighbors or links discovered. These links are plugged in. I can also create my own links between switches if they would not be plugged in. So I can build that. I can model that network if you want to. And at that point, I would say, go and generate my configurations. You haven't seen me entering any like router OSPF or IP address, right? I don't have to enter an IP address. I entered an IP pool, and it derives out of that IP pool the necessary subnets wherever I need. So I'm creating loopback 0, loopback 1. I'm creating point-to-points. I'm creating a rendezvous point if I need to. I'm creating a route reflector if I need to. But I haven't entered it at all, right? The system does it for me in a best practice kind of manner. That's what we deliver out of the product with Fabric Builder or Easy Fabric.
What's the underlay protocol?
In this case, I think I selected OSPF.
Okay. So you have a choice.
I have a choice. Easy Fabric supports OSPF and ISIS, and we're using the overlay control plane, namely EVPN with IBGP. That's where the tradition comes from of VPN address families and service provider networks. We also have the capability to build eBGP networks, and then we can manually add EVPN if you really want to and butcher it to something it was never intended to do. Right, Scott? You remember that discussion.
But you can't do EIGRP for the underlay.
I could do EIGRP. I'm not providing you with any template for EIGRP, but you can create an EIGRP template if you want to. So I'm going to push this here. This will take a couple of seconds, and then you see the horse race of these individual switches, which are being published and made ready. But I don't let you guys wait until it's done. I'm going to switch over to another fabric. Before I do this, I want to just give you a short overview of how the configuration actually is being built. So you see this list of templates. These are all little pieces which then, as a result, build your show run. All of these pieces can be viewed or edited. Let me see. For example, I took here a policy which was set with border. I can go and change that if I want. How does such a template look like? You see here my template library. This template library will be shipped with the product, will be updated as the product goes. I can open up these templates, and you see it is a set of form language, which defines the input, and a set of CLI. So guess how difficult it is to create that stuff or modulate that stuff if you really want. You have basically an open set of a tool library to build fabrics and to build networks if you want to. So that was day 0. Good? You guys like that? Seen it 100 times, doesn't work anyway when I want to use it. It actually works, and I want to show you that it works. So this is my second fabric, and you see it looks pretty much similar as before. I send configs down. I can actually go and look at the configs. Sorry, what did I do right now? Did I click something bad?
Just a curiosity question while it's thinking. When you were looking at the templates, and I don't remember the one you picked or one of the other screens, but it mentioned that it was just good for the Nexus 9K.
Yes.
Was that something that you had selected previously? Because the commands that I saw in there was kind of like those would work on other devices too.
Yes. So when you create a template, you have actually the liberty to select for what platforms this template is good. So you can literally create a template with the same name, but different switches.
But assuming these were built in, is there a reason that you would create a template that could be used on all of those, but just say it's for the 9K?
Sure. Yes. So we do certain fabric modes or certain ways of installing, which we are narrowed down to one set of platforms, but you're free to change. It's mostly how we built the product from a quality assurance and system testing perspective. We want to deliver you best practice templates.
Okay.
And these best practice templates will run against these sets. Excuse me?
You just made it really modular for me.
I made it very modular for you. Absolutely.
Okay.
Let me see. Let me close this here. Let me go back into Fabric Builder, and I think I told the switch to go into maintenance mode, which I actually didn't want it to do, but that's fine. So let me go here. Let me put him back into active operation. I mean, that's something DCNM also does. So software upgrade is one, which you can run through that, but maybe you want to take a switch first out of operation so you can do equally, put it into maintenance mode, graceful insertion and removal, and make sure that no traffic is being impacted there. But now coming back to what I actually wanted to do here for the demo, I wanted to give you a VPC domain. Can anyone give me the CLI commands for VPC? Anyone has it by hand?
Oh, come on, Scott.
I'm just thinking like,
Let's
not
practice
off the
those
top of my
CCIE.
head.
It's been a minute for me.
Okay, 4 times CCIE,
For the record,
right?
Yeah.
I do not have a data center CCIE. Yeah.
That's fine. Okay, so we've tried to stop with the madness of CLIs, and we just say, I want to do a VPC domain, I want to do a VPC pairing, and we even specifically in VXLAN EVPN removed the peer link. So you don't need a physical peer link anymore. You see me here, I'm selecting here leaf 83. I said I want to do VPC pairing. I want to use a virtual peer link. And actually, you see now there are 3 viable switches which could be a VPC neighbor for that domain. I used 83, so I will use 82, but equally it could be 81 or 82 because there is no physical link anymore in between this system. So I actually created right now with that single click and with this save and deploy a VPC domain and made it and staged it.
Wait, I might have missed something, but why are we doing VPC if you're doing EVPN? Isn't that unnecessary?
Good question.
Yeah.
When you want to dual attach hosts, we are still using VPC.
Under the hood.
Under the hood. The reason why we use VPC in EVPN still is the multi-homing approach is leaner with VPC than using EVPN multi-homing.
Okay. So you're not doing EVPN multi-homing?
We are doing EVPN multi-homing, but we are preferring to use VPC. We have experience that it performs better in the market.
Okay.
Even as we write a lot of the EVPN multi-homing code itself.
Okay.
Working actively as part of the IETF there, we are still very strong on the VPC side and we have a little bit of a head start there.
So what if you were in a mixed environment where you wanted to do EVPN with other vendors?
Sure.
Are you saying you can't support that EVPN multi-homing approach, or you can, it's just not the preferable way?
Yes, so we support EVPN multi-homing. It's actually, to be very, very frank and open, it's very, very hardware dependent. It has, specifically in IP overlays, it requires a function which is called MAC multipathing, which is not pervasively there in every hardware. So it depends on the hardware you select, but we have platforms doing this.
Cool.
We are doing EVPN multi-homing in these cases. We do EVPN interoperability actually for the last 6 years at ENTC. We're there with the 2 other original authors since basically day 1. And yes, we're doing interoperability testing, and it works actually pretty well. We can share the white paper as part of it. It's not too hard to find, but I'll go and definitely make sure that you guys get it. So I configured a VPC domain, right? You saw me that I clicked and I actually deployed, and it's now there. So how many lines of configuration it is again? I don't care. It was around 50 or something like that. I'm done, right? My VPC domain is there. I want to create a port channel down to a host. I'll go to my interfaces. Still, it's an interface I want to create. I want to create a VPC, and you see here under interfaces there is a VPC. Based on the selection that I want to do a VPC, it tells me where are actually VPC domains existing. I select that. I can change my ID. I don't want to. I just leave it as it is. And because I prepared a little bit here, I know that my server is connected on Ethernet 1/2 on both of the members of that VPC domain. I'll save it. I deploy it. And that pretty much is my interface being done. Right. So I did my fabric. I did my VPC domain. I did my VPC interface or port channel. And the only thing which is missing is now a service, which is the overlay. Right. I don't have VXLAN right now running. My pings are, let me see if my pings are working. What do you guess it works? Doesn't work. Doesn't work. So we have to go and figure out how we create that overlay now in this. And for that specific, we have here what we internally call the top-down deployer. It's creating a network. And again, minimal input. I want to use VLAN 10 because my server is already in VLAN 10. I want to use 192.168.10.1/24 for my host-facing subnet. And am I done? No, I need a VRF. You guys like VRFs? VRFs? Yes?
Mm-hmm. VRF.
VRF? It's a VRF. Okay, configuring a VRF, a lot of lines, not here. I just created a VRF and I'm done. So what do you see? And I stick to the VRF. What do you see here? Again, you have templates. These templates are in the template library. You can go and edit them. This is nothing else than a template of CLI commands and an interface or a view of how you enter data here. I create the network. I'm ready to deploy this now. And at that stage, I can select my switches. I can select my interfaces. And then at a given second later or so, I should have my communication layer 2 working between these two VMs. So I'm going here, leave 83. Actually going to select only one. Why do I get always two? It's a VPC domain, right? They're paired together, so I will not be allowed to individually configure them. I want to go to my port channel 1. On purpose, I only save or select one interface. If the other interface is the same, let me show you. By accident, it fills it in. If it's a different one, I can edit it and give another port channel there. If I think there should be additional configuration deployed, I always have something called freeform. Freeform is, let me add a CLI command, which I would like to have there. Let me similarly do it here. This is my other leaf where I have my other server connected. It's Ethernet 1.1. It's a single attached one. I'll do save. And now I have staged 3 switches which are getting a layer 2 segment. Where is it? It's further down here. Using a VLAN 10 to the host, it uses VNI 30,000 between the switches. When I want routing, I route in my VRF with a VNI of 50,000, and the VRF is called my VRF. And I'll go just here and deploy that. And this is pretty much how simple you could build a VXLAN EVPN network from scratch, deploy a couple of networks on top of it, and let host communication happen. Guys, believe me that it works? Barely? I would wait till it's green. Okay, it's green. Let me see. I actually don't know if it works. I haven't tested yet. But here, what's going on? At a given point, these interfaces will come up. Actually, they will not come up because I did a mistake. Have you guys seen what I did on the interface on the VPC when I created it? I said LACP. I don't do LACP down here, so I probably should change it.
LACP.
It's LACP, yeah. I should have put mode on, so it's, let me see. I can prove you that it actually is the mistake. But I don't want to steal too much time from my buddy Tim. We're still good, Tim? Let me see. Where's my interface? There we go, here it is. Let me edit. See, I even know my mistakes. Mode on, save, deploy.
Did it not do active to both sides?
My server doesn't do active.
Oh,
And I do suspend individual to avoid network loops when some of them happen. I think somebody teach me that as best practice. I'm not sure if you did any classes which I attended at a point. Anyway, but here we go. We have a ping, and you should be able to see that 1029 and 1027, they seem to be in the same subnet. And so that bridge over that routed network is actually working here. So VXLAN EVPN is in shape and running. And when we now go to the topology up here, as a final view for you, you can see DCNM supports multiple fabrics. You're not tied down to one single instance of a fabric per DCNM instance. You can actually run multiple of them. You see me here having that fabric demo 11, which I did previously. You see up here the monster I created, which doesn't look very nice here. And I can go and zoom in into the respective one and all the way down into the switch information if I want to, which brings it back into inventory lifecycle of the network itself. Backup, restore, rollbacks, and so on and so forth. This fabric aware, you have the template access if you want to. And that's what we call easy fabric. All right, with this, any questions?
Are you seeing slower load times and everything when you add more fabric instances?
Excuse me?
So say I have 50 fabric instances. Sure. Is that going to make my load time lag?
No, you should be perfectly fine on that one. DCNM has a limit of somewhere 250, 350 switches. So that's your operational domain which he can manage, so DCNM can manage. You can install multiple instances of DCNM. It's OVA, or it can be a physical server if you want to. And then if you want to create multi-DCNM manage, we actually can import DCNM and DCNMs and show you a single view of these different things. So there's always a CPU involved. The CPU is only involved for the management part. This piece over here, the network itself, you're on a different scale, basically the scale of the hardware of the switch itself.